Welcome to Biology 121, Human Biology and Evolution. My name is Megan Workman and I am your instructor for this course. I created this welcome video to answer some questions about how the course will run, how you'll get an A, and what my expectations are for my students. So first, let me explain that I created this course because I thought we should have a biology option that addresses big picture topics that I think a lot of people are interested in, like, is there an optimal human lifestyle, and if so, what does that look like? Is race real as a biological concept, and how does racism impact health? Are humans special among the animal kingdom? Who was the first human and where did she come from? How do genetic diseases work and why hasn't evolution gotten rid of them? And are some people immune to HIV? So as you can see, this list of topics, which are some that we're going to address during this class, isn't your typical biology course. These are complex ideas, and we are going to together evaluate the scientific evidence that informs the answers to some of these questions. Ours is an IN course. This stands for Integrated Lecture and Lab, which means that you will receive one letter grade for both the lecture and lab components. Ours is a virtual course during the pandemic, which means there is significant online coursework organized in the D2L platform, as well as one weekly synchronous session where you are invited to meet with me and your fellow classmates in a virtual classroom space through a platform called Bongo. And I'll tell you more about that in another slide. It's all accessible through D2L, and here is the web link to D2L. The weekly schedule will look like this. There's stuff for points that you will submit through D2L, like responses to case studies, laboratory activities that you will complete at home, and then answer questions that I can grade to make sure that you understand what you were doing for the lab exercise. There's weekly quizzes that are automatically graded in D2L. And then every week there's additional assigned stuff that you don't submit for points, but that you're expected to do as part of the learning process. This includes attending our virtual class if your schedule allows it. I hate to say that these are optional, but that is true. And I didn't want to assign points to the virtual class in case students have childcare responsibilities or appointments during that scheduled time each week. So I hope you can attend our virtual class sessions, but I won't take attendance. I won't mark you absent if you have to miss a day. Also not for points are study guides, which are a list of questions that you'll complete based on the assigned reading and videos and D2L web content that I wrote to supplement our textbook. And all of this is meant to direct your learning. Students always ask me about grading. How do I earn an A in the course? Please review this in more detail in our syllabus available in D2L. But here, let me give you an example. So our letter grades are based on the total points you accumulate throughout the semester. And if you want an A, which I hope everyone does, you'll notice on the listed point thresholds per letter grade that you need to earn 358 points from now until the end of the semester, and then you're guaranteed an A. There are a variety of ways to earn points in our class, including weekly submissions in D2L, which I mentioned previously. Those could include labs, case studies, quizzes. We also have one comprehensive exam around Thanksgiving, and at the end of the semester in December, a final presentation. And notably, none of these ways to earn points are weighted, meaning if you earn a point on a quiz, it's the same as earning a point on an exam. So it doesn't matter where the points come from, you're just focused on your accumulating point total. Each unit of work is organized in D2L in a similar way. So notice in D2L's content browser that Unit 1 is called Scientific Literacy, and then I've broken Unit 1 down into 3 subfolders, which I've called Lecture, Study, and Lab. Here, if I open up Lecture 1, you'll notice that there are Lecture 1 cues. These are some orienting questions. They're not for points. You might want to print them off and record your answers to these questions while you're watching the video lecture for that week, which is recorded in YouTube, so you can pause it. And these orienting questions highlight the key concepts I'm hoping you will learn from my recorded lecture. And that will become important for exams preparation. Under the Lecture 1 orienting questions is the web link to YouTube where I've uploaded our video lectures. And each week there may or may not be additional links that are referred to in lecture that might be short video clips or additional web resources that are linked to the lecture topics. So you're expected to watch these as well. And then at the end of the lecture folder is that week's case study, which is a real-life example of how the topics in the lecture show up in maybe the news or impact people's life today. And so you're asked to read that for homework and respond in D2L's discussion feature to some reflective questions that I will read your responses to and assess how well you're incorporating the case study information into the broader topics of the unit. So I hope that you find the case studies interesting and they're meant to be kind of fun. So this is a low stakes assignment each week. Here's an example of a case study. It's just an extension of the lecture topics. You read it, you answer some guiding questions, and you post your reflections about the case study in D2L for points by creating your own discussion thread or perhaps responding in a collegial, respectful way to something another student has posted. The next subfolder under Unit 1 is Week 1 study materials. And so here I've opened that up in the content browser. And the first thing listed is a study guide that highlights the key concepts that you're supposed to glean from the assigned reading and videos. And under that are some D2L lessons, which are part of the assigned reading for that week. These are websites that I wrote to complement the textbook. And at the end of each D2L lesson, there is a quiz that's assigned for points that you'll complete in D2L. It's auto-graded, so you can see your score right away. And you actually get 2 attempts to get 100 on the quiz. It's open book, open notes. So how do you know what to study each week? Well, the study guide spells it out for you. Here's an excerpt from Week 1 study guide where you can see at the top it lists the assigned readings and videos. And then under that are study guide questions, which are meant to direct your focus when you're watching each of the videos or reading each of the assigned reading segments. If you can answer all of these study guide questions, you will be in good shape for the exam. The last component of each unit is the lab exercise. When I open up the lab folder in D2L, the list of required checklist items looks like this. At the top is a worksheet, which you may open in Microsoft Word, or maybe you want to print it in order to record your laboratory results. So you're performing some sort of lab exercise at home, and on the lab worksheet there will be questions you can respond to. Under that is the list of instructions for each activity. So for Lab 1, there are 2 activities, Activity 1 and Activity 2. You'll follow these instructions to complete the worksheet. And then when you're all done, you'll take the lab assessment quiz in D2L, which includes some selected questions from the worksheet. They're taken verbatim, so then you can type in your responses. Sometimes they'll be mathematical responses, so you can type in the numbers. More often they are thought questions, so you'll type out a small paragraph explaining to me your understanding of the lab exercise, and then I can read and respond to you in the D2L gradebook. Here's an example of what a lab worksheet looks like. Notice at the bottom where it says required laboratory activities, there are 2 listed for this particular week. And you complete this worksheet, as I said, and when you're done, submit selected answers in D2L for me to grade. I mentioned that ours is a virtual class, meaning we have a synchronized session once per week. This is where we will meet together in a virtual classroom on Tuesday mornings, starting at 9:45, and I imagine we will meet for about 1 hour. How to access this virtual classroom is by logging into D2L, clicking on course resources. You can see here where I've clicked on that, and then scroll all the way down to where it says virtual classroom. I've highlighted it in yellow here. That will pull up a list of all of our scheduled meetings. Ours is a 14-week course, so we have 14 virtual classroom meetings scheduled. And you'll see that it says to please read the case study and watch the recorded lecture video prior to class. That will enable us to discuss sticky points from the lecture. We can discuss those lecture questions if you weren't able to intuit to the answers to them. And this is a place for us to discuss any questions or concerns you have about the class. So I hope you will be able to make it at least some Tuesday mornings. Also, if you'd like to meet with me outside of this time, just shoot me an email and we can discuss one-on-one in an office hours type situation at your convenience. So I'm available most days by appointment. All right, so ours is an elective for natural science lab credits. Probably you're taking this class as part of your AJAC or another program. It's not meant specifically for biology majors. That's why I thought we should have a course offering that talks about bigger picture topics. And so, as an introduction to our class, I wanted to mention that I'm a scientist. Before I became a community college teacher, I worked as a professional scientist at a university in Chicago. And from that experience, I learned that science is really for everybody, and you can do it for a career. So if you decide that this is your jam and you want to pursue it professionally, I am here to help you do that. And there's all different types of scientists. I'm a biologist, biochemists, neuroscientists, animal behaviorists. These are other types of biology folks. But there's all sorts of science. Planetary geologists, aerospace engineers, physicists, conservationists, nuclear engineers. And what all of these professions have in common is that we use the same type of thinking to ask questions about the natural world. And no matter what science you're into, you'll follow the same logical process to investigate these questions. So my job as your science teacher is to coach you to think like a scientist. To do so, let's briefly, as an introduction, talk about what science is and what it is not. So science is not an encyclopedia of facts. Instead, it's this thought process. It's a standardized way of asking questions. And scientific styles of inquiry are based on a few assumptions. The first assumption is that one objective reality exists. Whether or not an individual can understand it, reality exists. It doesn't depend on individual beliefs. This is the first assumption of scientists. The second assumption is that of all of that reality that exists, humans can, in fact, understand some of it. So here's an image of a guy pondering the vast expanse of the universe. That might be all reality. And what scientists assume is that within all of reality, humans have the capacity to know some of it. So here, this knowable realm is only part of all reality that exists, and it's limited by the capacity of our human brains to even perceive that this exists. Within this knowable realm, scientists assume that we can only actually test some of it. And this is what separates science from other fields of study. This yellow circle, the most small in my nested Venn diagram here, is the part of knowable reality that is refutable. That means we can design a test to prove it false, if indeed it is false. It is this yellow circle that science investigates. Science is a tool for studying this section of reality alone. And as you might imagine, as technology improves, this circle expands. An example of the expansion of this testable, refutable part of knowable reality is the invention of, say, a microscope. Before microscopes, people may have had ideas about tiny, tiny creatures, but they couldn't see them, they couldn't observe them. And once microscopes were invented, then all of a sudden this tiny micro world of observation opened up. And then scientists could design tests and could study these microorganisms, and so the bubble expanded. Studying observable, knowable reality in this way has led to all sorts of scientific knowledge, and it works. It landed men on the moon and brought them safely back to the earth. It cured diseases like smallpox. Here's a picture of a child from many decades ago suffering from smallpox, which was a debilitating and often fatal disease. Here's pictures of polio survivors. If you've been vaccinated against polio, you are protected from the devastating effects of this disease. And the vaccine was produced through scientific inquiry, as was our favorite technology like our smartphones, and my personal favorite technology, birth control, which allows half of the world's population to decide if and when they want to start a family. Medical technologies like this MRI, our cars, our airplanes, agriculture that feeds 7 billion people, entertainment, all of these industries are affected by science. So I think science is really cool. I may be a little bit biased, but I'm hoping that some of my enthusiasm might rub off on you this semester. If you have any questions about the class or about science, feel free to email me here at mworkman@pima.edu. I will try my best to respond to your email within 24 hours. I might be a little slower on the weekends or holidays, but I check my email frequently. So, now that you know a little bit about science, with a partner, I'd like you to practice naming something that science can study and something that science cannot. So you may just talk this through with your pet as your listener and explain it to them. And if you need some help, refer to the Unit 1 D2L lesson that explains in more detail what science is. And that is actually your first assigned reading for our class. A little preview of what's next. Please review the entire syllabus and email me if you have questions. Proceed to Unit 1 and D2L. Notice that our first extra credit possibility is due September 5th at 11:59 p.m. in D2L. Our first synchronous session, this virtual classroom experience, will happen Tuesday at 9:45, September 8th. And our first homework is due the next day, September 9th, where you will submit your discussion threads related to the first case study.